Hello everyone, welcome back to the Java tutorial series. In this video, we will learn about the stack in Java. By the end of this video, you will understand what a stack is, how it works, what are the operations, and where it is used in real world applications. So let's get started. So what is a stack in Java? So a stack is a linear data structure. Stack is a linear data structure that follows last in first out principle. So it is a linear data structure which follows LIFO principle, last in first out. Okay, what does it mean, last in first out? So let's say we have one stack, okay, and we are pushing one elements. Pushing means adding, okay. So let's say I added 10, then I added another element 20, then I added another element 30. Okay, so I am keep on adding elements, okay, 10, 20 and 30. So what was the last element I added? 30, right? So 30 was the last element added, okay. So this principle is saying last in means element which inserted last, that is 30, will be first out. That means out of this stack, let's say I added 3 elements. Now I want to pop the element. Pop means remove the element. Okay, so which element will get removed first? So the element which is lastly added, that element will get removed first. So 30 will get removed first. 30 will remove. Okay, so the principle is saying last in first out. Okay, this means the last element added to the stack is the first element removed. Okay, and it belongs to package java.util. So whenever we'll use the stack in the programming stack class, we have to import with the java.util package. Okay, and we have seen how last inserted element will be removed first. So stack is a linear data structure and we are following principle last in first out, that is LIFO. Okay, so let's have, so there are different stack operations. So before this I will take one examples. Okay, let's say we have one stack of let's say plates, you can say. Okay, so you can imagine in real life how this stack works. So these are the plates, you can imagine plates. Okay, so stack of plates. So these are the stack of plates. So we are adding, there is, imagine like there is one container. Okay, there is one container and in this container we are adding plates. Okay, we are adding plates. Now imagine you have inserted 1, 2, 3, 4 plates. Okay, and now you want to remove. So can you remove the last plate? Can you remove the first plate which you inserted first? No, right? So which plate will be removed first? So the last plate which you inserted in the container, that will get removed first. So that is the stack. So last element will remove first. So last element will remove first. So last inserted element will be removed first. Okay, last in first out. So a stack of plates is a simple real life example. We always place a new plate on the top and remove the top plate first. Okay, a stack in Java behaves the same way. That's why I'm telling this example. So I hope it is clear how stack works. Now we will learn what are the operations we use to perform this activity. Okay, so there are different operations such as push, pop, pick, isEmpty, search. So these are the essential operations. Okay, so the stack provides 5 commonly used operations. Okay, so push will, what it will do, push means add an element. So let's say we have one stack. Okay, and I want to add element in the stack. So which operation I will use? Push. Push means adding element into the stack. So I added 10. Okay, now again I want to add one more element. Then what I will do, again I will use push operation and 20 will get inserted. So push is used for add an element to the top. So whenever we are adding new element, that new element is going on the top of the previous element. Okay, and suppose I want to remove the element, so I will use pop operation. What it will do, it will remove from the stack, but which element it will remove? Okay, which element it will remove, that is important question. So pop will remove the last added element, so it will remove 20. Okay, last added, or you can say top of the element. So pop operation will remove the top element. Okay, it is written, see, remove the top element. So push is used for adding element to the top, and pop is used to remove the element from the top. Okay, and there is another operation called pick. Okay, pick means view the top element without removing it. You imagine, like, you want to know what is the topmost element. Just for knowing that element, top element, you can use pick. So if you use pick operation, you will get value 20. Why? Since 20 is the topmost element. Okay, and let's say if you have removed 20, then topmost element will be 10. Okay, so pick is used to view the top element without removing it. We will not remove, we will just get the information. The top element is empty. Is empty means it will check whether the stack is empty or not. If we are not having any elements inside the stack, is empty will return true, is a kind of boolean value. So if stack is empty, it will return true, and if stack has any elements, even if it has one element, it will return false, because stack is not empty. Okay, and search operation is used to find position of an element. So in search operation, we will find the position of an element based on the value of the element. So search is used to find the position of an element. Let's say we have 30, 40, like that. We want to know the value of position of 30 element, then we will use search operation. Okay, so push adds an element, pop removes the top element, pick returns the top element without removing it, and is empty checks whether the stack is empty or not, and search finds an element in the stack. Okay, so let's go to IntelliJ and see these operations by performing it. Okay, so we are learning stack. Stack is what? Linear data structure. Linear data structure which follows which principle? Last in, first out. That means whatever element we inserted last, that will be first out. Okay, you imagine the example of plates, it will be more clear. Then let's say, so stack is built-in class provided by Java. Okay, and we have learned generics. So stack, okay, so we will be having a stack of, it can be integer number, it can be string number. So during compile time only, compiler will check which type of data type we have provided. So let's say we are creating a stack of integer. So in this stack we can keep only the integer values. Okay, stack and equals to new stack. Okay, if you see in the top, the package is java.util.stack. So stack belongs to which package? Java.util. Okay, Now we have created one stack. So the stack class is available in the java.util package, and using generics we can create a stack that stores any type of object. Okay, here we have passed integer, we are using integer, but we can use string or any custom class also based on our need. Okay, so what and all operations we know? Push operation. Okay, push operation. So push operation, for what purpose we use that push? So push is used for adding an element on the top of the stack. Okay, boost is used for adding element at the top of stack. Okay, so let's say now stack is empty, right? Now I want to stack.push. Push is what built-in methods provided by Java, and stack.push I want to add element, but which type of element we can insert? Here in the generics we have provided, right? We have written integer, so only integer we can provide in this stack. If we go for string, then it will throw compilation error. See, anything we see, it is showing compilation error. So we don't need to provide any other data type other than integer. So I will pass here, let's say 10. See, no compilation error. Okay, so I inserted 10. Now let's say I will insert one more element, push 20, and likewise I will insert one more element, 30. So 3 elements I inserted, but don't forget to keep in mind the sequence how he inserted. So 10, 20, 30. So how it will be? So on the top 30 will be there. Why? Because I inserted lastly, then 20, then 10. So 10 will be at the bottom of the stack, then 20, then 30. So lastly I added 30. Okay, so this will be sequence. So which element is at the top? That is 30. Okay, now so the push method adds elements to the top of the stack. Every time I'm pushing, that will be added at the top of the stack. So when I added 10, 10 get added. Okay, then when I added 20, 20 added on the top of element 10, and when I added 30, 30 added on the top of 20. Okay, so the top element becomes 30. Now we will see another operation which is pop operation. So what does it do? Pop operation. Pop operation is used to remove an element from top of the stack. Okay, so if I perform like stack dot pop is also a built-in method provided by Java. Okay, so pop will simply remove an element from the top. We don't need to pass anything. Why we don't need to pass anything? Because whichever element present at the top, that element will get removed. Okay, so before that I will show here what is the current stack value. So I will print here. How we can print here? So if I go for like this, okay, let's run it and see. Since stack is in built-in class, what should be the output? Okay, it is showing in a linear way. Stack, see how it is showing. We are directly using inside print statement. Stack is a built-in class, and built-in class uses toString method inside the stack class, and toString method is used to print this value. Okay, in the later part of this video you will understand how this is getting printed just simply by printing statement. We are not using any loops, right, to print all the values. So using toString method present in the stack class, it is printing. Okay, don't worry about this thing, I will explain this thing later, but for now you can see, like if you want to print, you can simply print the reference variable name. Okay, so stack is like 10, 20 and 30. Yeah? Now we are performing pop operation. Now we will check which element got removed. So as per the definition, the top element we should remove, right? Top element 30. So it should be having 10 and 20. Let's verify it. So I will comment. Okay, let it be. We'll see both the output. So see, when we performed push operation, it was 10, 20 and 30. And when we removed one element using pop operation, the stack becomes 10 and 20. So the top element got removed. Okay. Now we have learned one more operation called peek. So peek operation, P-E-E-K. Okay, peek operation. What is the use of peek operation? It is used to view the topmost element, or you can say view the top element. That's it, top element of the stack. So which is the top element in the stack right now? Since while adding it was 10, 20 and 30 and we used afterwards pop operation, so it removed top element, that is 30. Now it became 10 and 20, and now we are performing peek operation. So which is the top element? 20 is the top, right? So it should give output. It should give output stack dot peek. Okay, stack dot peek should give the output 20. Let's verify it. See, in the output we can see, right, 20. So peek will return, this method will return the top element of an stack. Okay, so the peek method returns the top element without removing it. It will not remove, it will just simply return the element, topmost element. If you want to verify, I will print afterwards the stack. So it will, the elements will be as it is. Peek method will not remove the element. See, we have used stack.peek, so it is returning the top element, and we are printing afterwards the stack, so it is 10 and 20. 20 is not removing. Okay, so peek will just to identify the topmost element, and the stack remains unchanged after this operation. Okay, now there are two other methods, right? isEmpty and search. So what is the use of isEmpty? isEmpty means we are checking whether the stack contains any elements or not. Okay, so let me print here. So it will return Boolean value whether the stack is empty or not. If it is empty, it will return true, and if it is not empty, it will return false. Since we have two values 10 and 20, it should return false. Why? Because it is not empty. Let's verify it. So in the output we can see it is false. That means stack is not empty. Okay, likewise we will search the index, search the position of the particular element. Okay, particular element, like that is stack dot search, and we will provide the object or the value. Let's say I want to find out the position of 20. We have two elements in the stack, 10 and 20. 10 at the bottom and 20 at the top. Only two elements, right? So let's verify it. So we are searching value 20. So the search method returns the position of an element from the top, and if the element is not found, it returns -1. Okay, so there is a different time complexity, or you can say complexity, for push, pop, peek, and isempty operations. I will give you a brief of complexity. Okay, complexity. So complexity is a measure of how efficient an algorithm is. Okay, so we have two types of complexity. Let's say we mainly see time complexity, and there is one more called space complexity. Okay, time complexity means how much time an algorithm takes to complete. Okay, how much time algo takes to complete, and space complexity measures how much space means memory, how much memory, or you can say space, an algorithm uses. Okay, so we have time complexity, we have a space complexity. Time complexity means how much time algorithm takes to complete, whereas space complexity means how much memory, or you can say space, an algorithm will use. Okay, so time complexity measures how the execution time of an algorithm grows as the input size increases. Okay, so it does not measure the actual time in seconds. Okay, what it will measure now? It measures how the number of operations changes. Okay, let's say you have an array of 5 numbers. Okay, 5 integer numbers, and the time it is taking for that 5 elements to traverse. And let's say if the size of these elements, size of this array is getting increased 5 to 10 elements, then 10 to 100 elements. So on this increasing size, how the time is changing, it is whether it is linear. So that changing of time is measured with the term called time complexity. It can be O of n, O of 1. Okay. And similarly, space complexity measures how much extra memory an algorithm will needs while executing if the size of an array will increase. So these are the two things we see. So in stack we are seeing different operations like push, pop, and peek, isempty, okay, and search. So for these, what are the time complexity? So time complexity is represented by O. Okay, so for push operation it will take O of 1. For pop operation it will take O of 1. For peek operation it will take O of 1. Okay, and isempty it will take O of 1. And for search it will take O of n. Why it is taking n for search? Because in the stack we will be having different elements, right? Let's say if we have 10, 20, 30, 40, 50, and search is performed from top and it will go up to bottom. Let's say I want to find out the element 20 and I'm performing search operation for element 20, then search will iterate from top. It will start searching from top and it will go up to bottom. So it is traversing to each element. That's why it is O of n. Okay, and for push operation, O of 1 means simply it will add an element. For pop, it will remove an element. Peek means just will try to find out the top element. So for these operations, we have O of 1 time complexity, whereas for search, we have O of n time complexity. Okay. These are the basic operations and how to define stack class. We have seen with the example stack and the generic class parameter. So this stack will contain values of integer type. Okay, so you can store any type of object using Java generics. So here we can have string, okay, string, stack of string, stack of double, stack of float. Okay, based on need, we can provide. This is the advantage of using generics. Okay, and we have learned queue also, right? So there was a stack and queue. So the principle we follow in last in, first out. Whereas in queue, first in, first out. Okay. So queue is simply like wherever you go, you are first in the queue, first in the line. So you will be served first, right? So likewise, this follow principle, first in, first out. Whereas in stack, it is opposite. Last in insert element will get first out. So stack has only one end. Okay, from the top only elements can get removed. Whereas in queue, it has two ends. Why? Because from the front, elements will get removed, and from the bottom or from the end, elements will get inserted. You can imagine of queue, okay, in any of the service. Okay, so you are standing in the queue. So if you are in the above, you are in the front row, front line, then you will be served first, and this queue will be keep on adding. Okay, elements will get keep on adding. So this is the basic difference between the stack and queue. In topic DSA, data structure and algorithm, we will implement this stack and queue in the coding part, and we'll see how it works in detail in that area. Okay, so stack follows the LIFO principles, while a queue follows a FIFO principle. FIFO means first in, first out. In a stack, insertion and deletion happens at the same end. It has only one end. Whereas in queue, they happen at opposite ends. Okay. So these are the applications of stack. Okay. So method call stack, undo redo, browser back, expression evaluation, parenthesis matching. This is one of the famous interview questions. Okay, we will see this thing in interview questions playlist. Okay, and DFS. Okay, it is like BFS, DFS, depth first search. We will see in DSA these things, but these are the application of stack. So stacks are widely used in many applications. Okay, including method call management, undo redo functionality, and browser history navigation, expression evaluation, parenthesis matching, and DFS, that is depth first search. So these are the application of stack we use in the application. Okay, and so let's quickly summarize what we have learned so far. So stack follows the LIFO principle, LIFO data structure, that is last in, first out. So whichever element is lastly added will get removed, for that is last in, first out. And we have seen different operations. Push is for adding an element in the top of the stack, and pop is for removing the element from the top of the stack, and pick is for viewing or identifying the topmost element of the stack. So push, pop, and pick, time complexity is O of one operation, whereas we have seen for search, time complexity is O of n, because it has to traverse through each element. And we have seen real world applications, and array DQ is preferred over stack, okay, nowadays. So that's all for this video. I hope this tutorial helped you understand the concept of stack in Java. Thanks for watching, and I will see you in the next video.